So how do you know that you're actually getting something that's worth doing and not just, as John Oliver would call it, salmon jizz?
Yeah, he
So-
leaned on that word a lot. Yeah, the name is super unfortunate. People need to figure out a better name to use for this product, but there actually is real science behind it.
This is MedSpa Mayhem, the podcast all about the chaotic world of medical aesthetics. From Botox to lasers to IV bars, learn how to tell real versus fake, legal versus illegal, and safe versus potentially deadly. Hear the crazy stories inside the med spa world and find out what questions to ask and how to spot the people cutting corners. I'm your host, Dr. Kate D. Together, we explore the wild west of medicine that is the aesthetics industry. Hi, this is Dr. Kate D., and I'm speaking today with Dr. Flora Waples. She is aesthetic medicine specialist in Chicago. She grew up in Montana, went to the University of Chicago for undergrad, getting a Bachelor of Science, and then her MD at Cornell. And she is in practice with a whole series of medical spas in Colorado. So maybe you can introduce yourself a little bit better than I just did. Tell our audience exactly where you're located and what your spa is called.
No, so you did a wonderful job. Yeah, no, you're absolutely right. I went to Cornell. I went back to the University of Chicago for residency and studied emergency medicine and trauma, of all things, because I was young and it was fun and exciting. And I did that for 15 years. I spent 15 years, in the trenches in emergency care. And what I discovered in that time is something I think a lot of people in this country discover, which is that in medicine in this country, we intervene far too late. Right? Like every intervention that we do is usually by the time disease has already been established, the patient's already sick, and we spend a lot of time, accomplishing very, very little. And it became very frustrating to me. So about, I guess, 12 years ago now, I left the emergency room and I opened Restor Medical Spa with my sister, who is also my business partner. And with the idea that we wanted to be able to help people while they were still healthy. And so at Restor, we do both wellness and aesthetic medicine with the goal of kind of, look as good as you feel and feel as good as you look. We have 3 locations open in Denver metro area. We are opening our 4th this fall. And it's just been such an exciting ride. It's been absolutely wonderful. And I love the work I do. So that's kind of who I am.
That's awesome. I had a very similar experience, what we were doing. I actually really hated my internship. I did internal medicine, and I just felt like we were doing everything way too late, and we were mostly torturing people as they were dying. And it was so painful, incredibly painful. Yeah. I really did love working in breast cancer, actually. I did that for 16 years, and I felt like I was really helping people, and we were helping people to live, right? It was really a very positive thing. But I also left around that time, little later than you. It was about 10 and a half years ago now. But anyway, thanks so much for coming on the show today. So we have a lot in common. We have a lot to talk about. But today, I would really like to talk about salmon sperm or something else. We're going to call it something else. But like, why the heck are we talking about salmon sperm in this country? And if anyone hasn't seen the John Oliver episode that came out just 2 weeks ago now, it is all about MedSpa Mayhem. I mean, it's basically all about the book that I wrote. They investigated everything, and it was hilarious. So we are totally going to have the link to the John Oliver show in the show notes. And one of the first things they talk about is how, everybody is using salmon sperm now. And that got us talking because there is some science there, right? So a lot of people are running with it in a way that maybe is in the wrong direction. But I really was hoping to talk to you about why it's a thing and what's good about it, what's ridiculous about it, where, and so how do you know that you're actually getting something that's worth doing and not just, as John Oliver would call it, salmon jizz.
Yeah, he leaned on that word a lot. Yeah, the name is super unfortunate. The name, people need to figure out a better name to use for this product. But there actually is real science behind it. I will walk through the science, and also I'm going to I'm doing this for sort of as I would speak to a patient, obviously not as I would speak to another physician.
Absolutely.
But
Yeah.
I'll walk through this. It's kind of a long explanation, but but I will get to a good place, I promise. All right. So the basic idea comes to our skin has the ability to regenerate. It's a really an amazing organ. It has the ability to regenerate, which very few organs do. We take it for granted, right? Like you cut your arm and new skin grows, and you're like, but if you like grew a third kidney, you'd be like amazing, right? But we just take it totally for granted. But we have the ability to regenerate. But skin is very similar to muscle in that it's a lazy organ. It does not want to expend a whole bunch of energy and regenerate when it's not necessary. So the way that your body decides when to turn on that sort of regenerative machinery, if you will, is skin and muscle both respond to stress. So if you want to build a muscle, what do? You go to the gym, you lift heavy weights, you put the muscle under stress, and over time, gradually the muscle will regenerate, right? Well, skin is the same exact way. We put skin under stress in aesthetics all the time. We use, lasers use heat, microneedling uses physical puncture. We have all of these tools where we put the skin under stress, create these tiny microscopic wounds. The skin recognizes that stress and responds with regeneration, right? So this is a concept that's been around for thousands of years. Cleopatra used to take baths in ass's milk, which is an acid, so people have been using this idea of controlled wounds to regenerate skin for literally thousands of years.
Right. And for our audience, if you have listened to previous podcasts, we've talked a lot about this, about different ways to build collagen and elastin inside your skin, which is basically regeneration. So just in case you're following from previous episodes, we've talked about this before, but
this is what we all do day in, day out. But controlled wounds have problems. Whenever you are wounding the skin, there is pain, there is downtime. There's going to be redness, there's going to be inflammation.
Do you hate? I suck at pain. Actually, I have like no pain tolerance.
It's not pleasant. And there's risk of infections, risk of scarring, risk of pigment. There's all these things that go along with creating that controlled wound. So people have been searching for a long time for how can we skip that wound part and just get straight to the regeneration? And the answer is the way that your skin communicates with itself is it sends out these molecules called growth factors. And basically what it does is if a cell has been damaged, it sends out these molecules that says to the other cells around it, hey, I'm in trouble. I've been damaged. We need help. Send reinforcements. And so what people have been trying to do is they've been trying to get just those messenger molecules. And if you can put just those messenger molecules into the skin, then maybe you don't need to create the wound in the first place. You can just go straight to the regenerative message, right? So this is one of the most simple and elegant ways to mimic a wound. Well, it's by taking things that are supposed to be inside the cell and only inside the cell and spilling them into the tissue. So for example, our DNA. Our DNA is designed to stay inside our cells, right? That's where it's supposed to be. That's where it does its work. If a cell, the only way DNA can get out into the bloodstream or into the tissue is if a cell gets torn open, if a cell is spilling its contents, okay? So as it happens, fragments of DNA are a really potent stimulator of regeneration because your body interprets that, reasonably so, as there's been a wound nearby, a bunch of cells have just been broken apart nearby, right? So people basically doing this kind of regenerative research realized DNA, tiny fragments of DNA called polynucleotides, which is the formal name of salmon sperm. It is PDRNs or polydeoxyribonucleotides. Realized if you have very small fragments of DNA and you put that into tissue, the tissue responds with actually very robust regeneration. It interprets that as it would interpret a wound signal. So that's how we get to the DNA. That's how we get to that piece. Now, why salmon sperm? Because you're right, it's ridiculous.
Yeah. So so you need a source of DNA, which means you've got to destroy some kind of cells to release these bits of DNA. And why salmon sperm more than any other source?
There's a reason. There is a reason why. So the PDRNs were all developed in Europe. Europe has, or at least so far, have been developed in Europe. Europe has very, very strict laws in terms of how animals can be used ethically. Right? In order to develop this product, you need a DNA source, right? Which has to be, an animal. And you need to be able to get that DNA without harming the animal. in order to sort of get past the regulators in the EU. Well, there's only one circumstance in which an animal is ever going to get its DNA outside of its body, and that is to mate, because DNA is an expensive molecule to make. It's energetically difficult. It's very complicated. So only in a mating situation is an animal ever going to be like sort of throwing industrial amounts of DNA out there into the environment. So what they chose to do is
unless you
salmon,
so without killing. So the
without
idea is
killing.
you're trying not to kill any kind of
Exactly. Trying not
animal.
to kill
But
damage.
why does it have to be? Does it have to be a vertebrate? Can it be yeast? Could it be bacteria?
Well, I don't know if they experimented with yeast and bacteria. DNA is very highly conserved, meaning that it's very, very similar from one species to another. I don't know if they tried with bacteria and yeast. I think the trouble there would be you have to break the cells open to get the DNA out. And when you break the cells open, there's a lot of other stuff, for want of a better technical term, inside the cell body of a bacterium or a yeast that could potentially be dangerous to a human. With sperm, salmon jizz, if you will, there's no other stuff inside that cell. It's only DNA. And they chose salmon because there's commercial salmon farms. So salmon farms, you can procure large amounts of very pure DNA without ever harming an animal.
That's very interesting. So interestingly, many years ago, I had a patient in the breast center who worked in a fisheries thing, and she literally had to collect salmon sperm. And she was describing this to me because it's very physical. Salmon are kind of big. And she literally showed me how she would grab the salmon and basically milk it like a toothpaste, like a tube of toothpaste.
Yeah.
And her big concern was if she had breast surgery, would this interfere with her ability to get the sperm out of the salmon? So I actually kind of do have a visual for this, which, probably for good or for bad.
More than most people have, probably.
I know, which is very, because I was like, oh my gosh, well, we'll make sure that you can still, get the salmon sperm.
Yeah.
I didn't call it jizz. Okay. So I was very respectful about this career. So hold on. So really any sperm? I mean, what about all the sperm that goes flying around, from humans? I mean,
well,
does it matter whose sperm you use?
Quantity issue, and it's an ease of procurement issue.
Okay.
Again, I'm not an expert in why they use salmon specifically, but if you think about, like the amount that fish produce large, because they're trying to reproduce like in flowing water. They need to have a volume. Also,
so they're high volume sperm producers, is what you're saying.
If I was raised on a cattle ranch, so I know something about how we go about getting this from cattle and horses, and it's very labor intensive and quite dangerous. So I suspect it has to do with just ease, but that
could get you trampled. So salmon, all they could do is swim away. They're probably not going to hurt you.
Yeah.
Okay. So, but this is interesting though, right? So theoretically though, you could use sperm or from any animal source. We're not sure about other DNA, but yeah. So you really want pure DNA. Okay. So then I'm curious though, how do they, once they have the salmon sperm, how do they treat that in order to extract these little bits of DNA?
I'm not an expert in the biochemistry of exactly how they do it, but I know that what they do is they break open the semen, they get the nucleus, the DNA material out, and then they break it into very, very small pieces. So what you're getting is purified deoxyribonucleotides, which are the building blocks of DNA. You don't want to have long strands of it. What you want to have is it broken into small pieces, because that is the biggest signifier to your body that there has been damage in your body.
There's damage. Right. So the whole point of the salmon sperm thing, which we're calling it, PDRNs, all right, is that we're trying to tell the skin it's been damaged and do some repair work so that you grow new collagen, elastin.
And you're trying to trick the skin into thinking there's a wound nearby.
Okay.
And fragments of DNA happen to do a very good job of tricking the skin into that. And so when you apply this, either injected or topically on top of a laser or something like that, what you get is reduced downtime, increased healing, improved collagen synthesis up to 80%, and you get really, really good pigment control. It regulates the fibroblasts really well for reasons that are not entirely clearly elucidated in the literature, but you get really good pigment control as well. And so that's the reason why someone would ever do such a thing, is because you get really good skin regeneration with it, with very little need to wound. That's the But the name's unfortunate.
And so you're either applying this topically or potentially injecting it, or using something like laser, which increases the absorption of things to allow the topical application to actually be absorbed better. Am I getting that right?
Yeah, exactly. And in the US, Right now, it's FDA approved for topical use. In the EU and most of Asia, it is approved for injectable use. In the US, it's not approved for injectable use yet. Some people do it off label. The stuff that we do, import from Europe is sterile. It's appropriate for injection, but it's not FDA approved for that in the US yet.
Okay. Are there any adverse reactions when it's injected?
I have never seen one, never read about one in the literature. Because if you think about it, DNA, especially when you're talking about DNA of a vertebrate, is identical. There is no molecular difference between a
Sure.
ribonucleic acid that comes from a salmon or a cow or a dog that's different from a human. So there's no ability, as long as it's been processed correctly and all of the sort of foreign animal proteins have been removed from it, it
Right.
is
So it
something that's
really has to be
bioidentical.
pure. That's the big
Yes.
thing. It has to
Yeah.
be pure.
Or it has to be
And
sterile, especially if you're putting it on open skin, must be sterile.
okay, is there one manufacturer of the PDRNs right now?
I will tell you, the one that I use is Promo Italia. They've been manufacturing them in Europe for, I believe, about 14, 15 years.
Oh, wow.
So I use
Okay.
their PDRN. There are a couple other companies that do it. I don't know the names off the top of my head, but
Okay.
it's become a relatively common aesthetic adjunct in most of Europe and Asia.
That's so interesting. So we're just sort of catching on here, even though, yeah, it just
Yeah.
hasn't. So when did it get FDA approved for topical
Last year.
use? Last year. So that's why
Yes.
it's brand new.
And
People are
that's
doing it. So that's what I try to get on top of is, I mean, this has been true in the practice, right?
mm,
Is, people jump on things, whether it's good or bad,
mm,
right? And we don't know it. And I'm not like usually the very first adopter, especially of things that are injected or applied, because I need to know it's safe, right? So it
yeah.
has to be around long enough to like prove that it's safe.
mm,
Although we do tend to get things here in the US much later. So
yeah.
Europe's had 10 years to figure out if anybody was going to die from
Yeah.
this or have something
Yeah.
bad
So we have a
happen. And
good, we have a good safety track record. Not in the U.S., but we do have a good, data chain, on using this. And interestingly, they are now several. I know that I believe that Mertz. There's a couple. They are now basically creating products where it's PDRNs that are inside of the HA filler syringes. So basically, you've got the
yeah,
PDRNs inside the filler itself, so you get this regenerative signal along with the filler, and that's pending FDA approval in the U.S. That's already being injected, again in Europe.
that's
So
really
yeah, no, people are
interesting. You'd
using it.
think you would get better results from your filler. I don't love the idea of mixing things with filler because I like
Mm.
to know when something goes wrong, what it's from. And filler is our number one thing we worry about that keeps us up at night. And so, I'd rather, I don't know, like I always like to have it separate. People are busy mixing stuff with filler, and it's never been a thing I've thought was the most brilliant thing to do. But anyway, yeah, I could be proven wrong. But what that's going to do is that just going to make your filler a lot more expensive,
And
right?
we'll see. Yeah, we'll see what they do with it. I mean, in Europe, of course, they have so many different filler manufacturers
Yeah.
that a lot of the filler is much cheaper over there. What'll happen when it
Yes.
gets here? Yeah, who knows? Who knows?
Yeah, that's so interesting. Okay, so how long have you've been using it here for as long as it's been FDA approved in the
It,
States?
not quite as long as it's been approved. We've been using it for about a year, sort of as an adjunct to our laser and microneedling therapies. I haven't been injecting it yet. When it gets approved, I'm excited to do that because I've seen the before and after pictures at various different talks and conferences I go to. The guys from Latin America and Asia will get up and they'll show these pictures, these before and after pictures, and they're like, I injected 4 points with a tenth of an ml, and 4 months later, boom, the patient looks 10 years younger. It's
That's
astounding.
crazy.
It's really cool. And we look at them, they're like, I'm like, great, where can we get that? They're like, oh, you can't get that, but we can do it. Look at it here. I'm like, well, damn it. That's just very frustrating. But
It
so
would it
it's,
would seem that it'd be really helpful if you could apply it, get it absorbed throughout the skin,
mhm.
that, not just injecting in one particular place, right? But if you could, so can you put it on right after microneedling or right after like non-ablative laser resurfacing and have it get absorbed well? I mean, is there data on how well it's absorbed
It
after that?
absorbs reasonably well. It is much more effective injectable. In
Okay.
Europe, they basically all they do is inject it. So it does absorb
Mm,
because DNA, as it turns out, DNA is something which your body is very familiar with dealing with. It absorbs very well and it spreads very well. So actually, you can do, they call it the 10-point lift, where they just do 10 injection points around the face. And it literally does spread everywhere. And you get signal that diffuses to everywhere. So it does actually work. I am excited for that day. But yeah,
so are they injecting it intradermally or underneath
sub
the
Q,
skin
sub
sub
Q.
Q? Okay, so so that's interesting because if you're causing tissue regeneration under the skin,
Mhm.
right, which is kind of the fatty layer
Mhm.
right beneath the skin,
Mhm.
right? What's being generated in the fat? Is that just more collagen because you're not you don't
Yeah.
have a lot of
You know,
fibroblasts
the
and
thing
stuff?
is, the thing about it, and again, I am not an expert in the injecting because I'm not allowed to do it yet. I hope to
Yeah.
become one in the future. But based on the lectures I've listened to and the people I've talked to about this, it diffuses really broadly. And the growth signal, because what you get is basically you get a growth signal. And the growth signal is not contained to a specific area. So we tend to think about, like, in the US, we inject tox, it stays in the space like that big, right? We inject filler, it stays hopefully right where you inject it. It's
Well,
not that.
hopefully.
This is not a synthetic molecule that you're putting in, you want to stay put. This is more like injecting, like a vaccine or something like that, where you inject the signal here and then it travels everywhere else.
Okay.
They only need to inject, every sort of 2 inches apart in order to get the entire face to respond. So it is a signal, not a something in not something in and of itself. It is a signal for your body to do something. It's not the molecule itself that matters.
Right. So interestingly, I did do a whole interview with Judy Rubin not too long
Mm.
ago, and we talked about primarily exosomes and then
Yeah.
also a little bit about stem cells.
Mm.
But presumably what's happening is the DNA fragments are triggering a response that says, "Hey, do some repair."
Yeah.
And what are the cells, that do that? It's, if you were using stem cells, I guess they would go straight to the area and
Mm.
start repairing. Exosomes also, from my understanding, like we also don't inject exosomes in my
Mm.
practice, but we do have them as a topical. Same kind of deal. That's like they go
Same
and they
concept.
and
Yeah.
they yeah. So do you ever use the PDRNs plus exosomes or stem cells or both?
Yeah, and that's a great question. And this is where you start getting into the Wild West kind of
It is
part
the
of it,
Wild
right?
West. But for everybody at home, this is the very much the Wild West because none of
This
this
is the
is
Wild West.
there's no
And
data. It's just like all theoretical. People are very interested in regenerative medicine because, in theory, it should totally work, right?
yeah, because they're being so
So,
huge.
and the problem is we don't have data for a lot of this stuff.
Yeah.
And the little bit of data we do tend to have tends to be from the manufacturer that makes the
Yes.
thing that wants to sell it in the first place.
Yes.
So the data from there is not necessarily the most reliable. So yeah, but can you comment about like where you think this is headed?
Yeah, I absolutely can. I'll also tell you why I use PDRNs and why I don't use exosomes. Because I thought about that and I demoed several of them and I did split face side by sides on myself. So if one side or the other looks great, that's how you know. But basically, the thing about exosomes, the word itself means nothing, right? An exosome is just an envelope. That's the analogy I use when I'm talking about patients. Exosome is an envelope. It's a phospholipid bilayer. An envelope doesn't matter. What's inside the envelope matters. There could be a
Very
letter
much.
from a loved one inside there. There could be a bill from the IRS, right? It could be good or bad. What matters is what's inside, right? And so what is inside exosomes tends to be this kind of slurry of growth factors. Growth factors is, I think of it as the traffic signals of the body. Your body can't read and it can't write. So the way it communicates, so the way cells communicate with one another is they exchange these molecules. And it's vastly complicated. There's hundreds of thousands, if not millions of these things. And they all mean different things. So it's like having this
Yes.
enormous, enormous alphabet. So when people make exosomes, the idea is that you put growth factors in there that are going to stimulate the body to do something, right? The problem is we don't understand that science very well. We just don't. There's so many growth factors. They interact with each other. They also interact differently with different tissues. And frequently manufacturers will do things, and this makes me insane. Okay. They'll do things like they'll use growth factors from plants.
Well,
And
yeah. No, I
oh,
mean, and
no,
we did
crazy.
talk about this on that episode with Judy Rubin, and so like in my practice, we use only platelet derived exosomes,
Right.
which we
Which
know
is
what those
rational.
signals do. Those are heal signals, right? And
Mhm.
then in her practice, she uses these exosomes that are human placenta derived, right?
Also
And
rational. Yeah.
yeah. And what people should know about exosomes is that, these places that are touting exosomes, a lot of them are using basically what we would call garbage. Okay. So it's from plants, which not going
Yeah.
to help you as a human, or it's from parts of humans that don't really cause healing or repair.
Right.
And And so there's a lot of junk out there. So you have to be really careful when people say exosomes. That is a generic term meaning the little packet of signals. But the question is, what signals are you getting?
And also, what language are they in? So the thing is, every species has growth
Yes.
factors that they have evolved that work with their own cells. And the closer a species is to a human, the more likely it is that their growth factors are going to be able to bind to our receptors. And so the analogy I use is like languages. Like if we're using, growth factors that are from, let's say, a primate, that's like somebody from Jamaica being able to speak to someone in New England. They'll probably be able to figure it out, right? They're close enough, they'll be able to figure it out. But if you're using an exosome from a plant, that's like somebody from China trying to speak to somebody from, England. The languages are so far apart. They may be able to figure some things out, but the languages are so far apart that we don't know if they will be able to communicate or not. And that's the problem. So the reason I chose PDRNs is DNA is very simple and it's very conserved. It's the same across species. So I know I'm getting a signal that the body will be able to understand. I believe the exosomes are something that will be widely used in the future. I think they have tremendous potential. I think there's real science there. I just don't think we understand the damn things. And so I wanted to use something that was simple, reproducible, stable, that I could understand. And so that's why I went with the salmon sperm.
Okay, so that makes total sense. Okay, so right now you're using adjunct to other treatments.
Yeah.
Can you elaborate on that?
Yeah, absolutely. So we use them topically. So what that means is that we rub them onto the skin after any procedure that opens the skin up. And you said it exactly. And that's microneedling, microneedle RF, ablative lasers. Essentially, that's it. Because these molecules need a way to get through the skin. The surface of our skin, its job is to keep the outside out and the inside in, right?
Yeah.
So if you put this on skin that hasn't been opened in some way, it's not going to get through. It's too large of a molecule to get through. So you have to open the skin in some way. And there's a bunch of different tools you can use to do that. And what we have found, and we did split face trials on all this because we wanted to see is, increased healing. The skin texture and tone is improved visibly. I've also found that the pigment, especially sun damage and melasma both, are visibly reduced, when we use this. So we just use it as an add-on for our lasers. And that's what we've been doing with it.
Can you do it as an add-on for like a medium depth chemical peel? Would that work at all, or would it not get absorbed?
Yeah. So
or would the chemical destroy the DNA in some way?
Yeah, I mean, it have to be neutralized. But I think the issue there, it would work. I think the issue would be the pain of application. Because, if you're applying it and kind of like rubbing it in, I mean, chemical peels tend to be very, very, very tender to the touch. Could it be done? I think it could be. I'm just
curious. One thing I would say with that, because I did an episode recently about melasma with a dermatologist we both very much advocate for using chemical peels for melasma. Sure. We can go back and listen to that one if that's really interesting to you. But so it would be really interesting, right, to know if that would add a benefit to that.
Yeah, I mean, that's one. There are no clinical trials done on that. So I would say the only way to find that out would be to do a split face, small scale split face study in your own practice. Things that, and this is the thing about a lot of, exosomes, PDRNs, things of that nature. You're not going to find a lot of literature. The manufacturer is going to do 1 or 2 studies, show efficacy, and then they're tapping out. So beyond that, you kind of need to prove efficacy yourself in your own clinic. It can be a bit of a stumbling block for some folks.
Well, it's really a challenge. I wrote a whole chapter about this in my book about why there are no studies of all the things we do in aesthetics, right? So basically, the big drug companies, right, have this giant R&D arm where they spend tons of money validating that their drug works, right? And that is all so that it will be covered by Medicare and therefore covered by insurance. And so they can make lots of money from it. So that's why those studies get done. But in aesthetics, it's all cash pay. And for anybody to just use something, all they have to do is sell it to you, and then they get money for it. And so the people who make these things, all they have to do is convince people in the industry to buy it and do it, offer it to pay people who walk in their door. And the problem is that our industry is filled with people who are not necessarily science geeks like us, right? And so they just buy these things and they just do them and they just collect money from them. And it's all about whether they can convince you to come in, walk in the door, and convince you that this is going to help your skin, right? And so, obviously I'm so busy here trying to figure out what's real, what's not, what works and what doesn't. It'd be great if we had more studies, but they're so expensive to do, right? No, you and I, we can't afford to sponsor these studies. These are really, really big studies, right?
Yeah.
So we know our own data, right? And we try to get as much scientific information about these things as possible, right? But it's still hard because we can't really rely on, we know about safety because a lot of the things we've been using have been around for years and years and years, right? And as new things come on, that's why I'm a little slow to adopt, especially things that get injected in people, right? Is because I just want to make sure, it's going to be safe, right? I did one episode a long time ago. We talked about IVs and IV clinics and stuff. And there's one case of this person died because a naturopath in San Diego thought it would be like super healthy to hang some turmeric inside an IV bag. And the person had, what do you think? What do you think happened?
I mean, anaphylaxis or
clot. Yep. See? Okay, you're an ER doc, right?
Yeah.
Now, any doctor would listen to that and go, oh my God, did they anaphylax and die? Well, yes, that person did. And the thing is, the naturopath didn't know that. And like, well, if it's good for you to eat it might as well be good for you in an IV. And actually, it has been done in IVs, but it's super dangerous because anyone could have an anaphylactic reaction to a weird molecule like that, right?
Yeah.
So anyway, so I'm a little nervous about new things. So, but the cool thing about this, so this is why I'm like trying to, we'll send this episode to John Oliver. Maybe he'll listen. I'm not sure, but it's really interesting, right? Like, okay, so if you have little bits of DNA, that's what it's doing, and it's that simple, right? You could get DNA from anywhere. Obviously, you wouldn't want to take, whole genes and put it in anybody, right? But even then, even if you took a whole gene, it really wouldn't be taken up and put into a cell and
well,
like,
I think
that was
one of their concerns when they were developing PDRNs was they needed to prove that the DNA was not going to be taken up. And so what because and for the listeners out there who aren't necessarily huge science geeks, we have evolved, all life on this planet has evolved. We love to swap DNA with one another, whether through mating with our own species or with a virus inserting its DNA into our genome. There's things called plasmids, which are just little circles of DNA that insert themselves into the genome. Absorbing DNA from outside sources is a wonderful way. There are risks to it, but it's also a wonderful way for a species to evolve. If you can pick up a whole gene from somewhere and don't have to evolve it yourself, which takes hundreds of thousands or millions of years, you can skip all that process and just gain a whole new ability, and that can be very advantageous. So our cells,
and also that's the basis. That is the basis for gene therapy, and those things are being actively used to try to cure diseases where you do have one particular gene that's messed up.
Because our bodies really want to do it. And so what they had to do to bring the salmon DNA to market is they had to show that they had a way to break it into single nucleotides. So what that means is our DNA is a long strand of hundreds of thousands, millions of what they call base pairs. These little, I think of them as Legos, these little individual Legos. And each one of those Legos is a base pair. When you put them together, you can build these very long structures. But when you break it down into just single base pairs, just the one Lego can't build anything. So even if it gets inside a cell, it's just one Lego. It's not going to do anything to the cell. So to answer your question, it is single nucleotides, and that's how they sort of assured safety in a situation where you're using DNA. And I asked that question of their chief scientist. I was like, I need to know why this is not going to insert itself into the genome. He's like, because it's a single base pair. I'm like, oh, okay.
Okay. And then they have a way to guarantee that they're single base pairs.
Yeah, they put them in with enzymes that just chop up all
that. Chop it all up. So the DNA has to be okay. Okay. So super interesting. And they can't self-assemble inside the
not without the enzymes. They're inside the nucleus, so you're good to go.
Okay, awesome. So it's really interesting, right? So potentially this has a really, really powerful ability to signal repair mechanisms. I am kind of curious then. So maybe you don't need exosomes if you're using PDRNs, but maybe stem cells would help. Conceivably.
Well, they actually are now coming out with products that, because again, exosome is just an envelope. It's a way to deliver a signal to someplace.
Yeah.
And so they are now making exosomes that have PDRNs inside them, because if you can get the signal deeper into the tissue, you can do other stuff with it. And so again, the PDRN itself is the signal, the exosome is the envelope. And so they are developing those. And for the same reason, is that DNA is simple and it's easy, and growth factors are complicated and difficult. So they are making exosomes that have PDRNs inside.
Right. Okay. Well, that's That's really
Same
cool.
concept. Yeah.
So if you're interested, if anybody listening, okay, is interested in finding out like where is doing this at the cutting edge, but they're not, like I would like to say, just full of crap, right? Okay. So, all right. So if somebody's really interested, what should they be looking for? Because it sounds like this is kind of spread all over the country. People are offering salmon sperm facials and whatnot. I mean, first of all, it sounds like a salmon sperm facial would be worthless because if you smear it on your skin, it won't get
Yeah,
absorbed.
without a microneedling, I think that most of those are done with microneedling, where you microneedle and then apply it. Yeah,
Okay.
putting it on just like dry skin that hasn't
That
been
makes no sense
deodorized in
at
any
all.
way.
Right. So clearly the skin has to be damaged in some way to put it on topically.
Yeah, you
So
got to
either
get
with a
it.
laser or with microneedling. Okay. So what would you recommend people ask if they're really interested in getting the actual benefits of salmon sperm and not something that John Oliver is going to make fun of
Absolutely.
next time?
Absolutely. I would two things. I mean, like, I think actually I say three, there'd be three things. First of all, it's just a general rule. You always want to make sure you're going to a reputable place, someplace that has a physician that's on staff, local, at least reasonably well educated.
Yeah.
You want those. That's true for every procedure you do everywhere, regardless. Aside from that, there are two brands that I know. One from Korea, and then Promo Italia, which is from Italy, that are, the one in Italy is regulated by the EU's version of the FDA. They have a 15-year track record, and they have their PDRNs are 2%, which is a high percentage by weight. And if you have less than 2%, you're going to get less of an effect. I demoed a couple different types of PDRNs that have 1% and 0.5%, and you just don't see as much. Make sure that you have a high percentage purity. You want to make sure it's coming from a reputable company that's got a reasonable track record. And so you can ask the place that you're going to just be like, hey, where do you source your PDRNs from? They should be able to tell you a company they're ordering from. And then that's
Um,
something that you can check on. Again, Promo Italia is the company that I use. I'm not a speaker for
what's
them.
the
I'm not
Korean
paid by them in
company?
any way. Oh, gosh, I knew you were going to ask me that. I'm blanking on it. It's their major companies. They also make
Okay.
fillers and talks and a couple other things. And
It's not the same company that makes Latibo. I just had to look that up for something else the other day.
Tebow, I don't remember, but it's, if you Google PDRN's Korea, it will be the
Hmm.
first one that comes. I
Okay.
don't
Well,
remember
if I
what
can
it's
find
called.
that, I will go ahead and put that in the show notes as
Do that.
well.
They have a 2%, and
Hmm.
I have not personally researched that company, but they seem to be
Yeah.
reputable, and a lot of people use them. With Provo Italia, what I did to like vet it for myself and my practice is I got on the phone. I basically badgered them until they let me talk to their chief scientist, which took a couple of weeks, but they eventually gave in. And then basically I asked them, like, here's all my sort of safety questions. Here's all my questions about how it's made, how does it work, why is it useful, what the hell are you doing? And he was able to answer those questions for me, and I was like, okay, and I'm good to go.
Interesting.
You want to find a reputable supplier, I think, and that's just, yeah, that's what I was.
So I love that you do that because I do the same thing. When I'm investigating something, I ask a million questions and I go over each person's head until finally they're like, "Oh, Dr. D, you just need to talk to our scientific officer."
Yeah,
And
that's
then
how somebody
and
knows.
then that's the person who knows. I find that to be super interesting. I'm actually demoing a laser later today
Yeah,
where I did exactly that. I just bugged them. So it'll be interesting. Actually, that'll be interesting. I'll report back.
these are
Future.
related.
Oh, it is the ultra clear, and it is the first ablative laser that I think might be safe enough for the MedSpa space, but
Yeah,
that jury's still a little bit out on that.
yeah.
It'll be, I think, maybe in the right hands. I feel that, with things that are constantly being delegated to the lowest person who you can pay to do it, ablative lasers just shouldn't, it's just, they're
It can be
much more
tricky.
dangerous, right?
Yeah, yeah,
And can you achieve the same result with a non-ablative laser? Maybe you do 3 treatments instead of 1, but if you
yeah,
can achieve the same result with a much safer laser, why wouldn't you do that,
yeah.
right? But what I really like about your approach is that you ask all those very difficult questions, and on average most med spas won't have asked any of those questions, and they tend to just buy what the rep sells them, and they
Yeah.
price it at what the rep tells them, and then they don't know how to manage the complications, and they don't know why something went wrong, because they just took it from a rep. And reps are just salespeople. They're not scientists. They
Yeah.
don't know. And so always, any place you're going to go get any of these treatments, just make sure it's a legit place, which is why we're very close on having our website for the Medspa board. So I'm very excited about that. I don't want to talk about it too much because I don't know when we're going to be able to launch it, but we will have a certification program for med spas pretty darn soon.
Would
So
be
hopefully within the next
great.
couple months,
Yeah.
we'll be up and running. It might not be beautiful yet by then, but it's going to be functional.
It's needed. It is. I
Yeah.
mean, just going back to John Oliver's, sort of, episode, like we desperately need a certifying body. We desperately need standards, because there's some brilliant people out there doing like amazing work.
Yes.
And then there's like Johnny the janitor, and he's like, hurting people. And it's just, and there needs to be very distinguished.
If you're listening, if you haven't seen the John Oliver piece, man. So first of all, it's only like 22 minutes. It's absolutely hilarious. And they talk about the good and the bad, but they really point out all the different aspects of what is wrong with the industry.
Yeah.
And the thing is, like, so how do you know, right? Like if you can get actual good results from salmon sperm, I mean, how do you know that you're going to a place that's going to do anything that's worth the money that you're paying, right? It's just really important. And that you're not going to get hurt. I mean, the one thing so far that I've heard from this whole discussion is that it is unlikely that any of the salmon sperm stuff is going to harm you.
That is, I have never seen.
Yeah.
I've never even
if it's real salmon sperm. So the thing that would make me very worried would be somebody selling you something and calling it salmon sperm. It's not, or calling it PDRNs, and it's
I think
not.
That would be
I think that is so, and that happens with Botox. It happens with filler. It happens with Kybella. It happens with all these products where people are buying it illegally. So if somebody is offering you salmon sperm or PDRNs or a salmon sperm facial or whatever, I would definitely ask what the manufacturer is and take a picture of it with your phone and then Google it. Maybe do that in your consultation first before you actually go pay for something like this.
So that's because it's going to be, it should be in a vial from the manufacturer, and it should have their logo and it should have their information on it. And if it's, I don't know, in a Gatorade bottle in the fridge, well, that maybe is an indication that it's not as
well, chances are they're not going to show you the Gatorade bottle. But and the other thing is, everybody should know it is not yet FDA approved to inject it in humans in the US. So now for doctors, doctors are allowed, and nobody else, by the way, nurse practitioners, PAs, they are not allowed to do things off label. Okay. Now PAs can do it under a doctor under certain circumstances, but anyway, it's very complicated, but doctors are allowed to use their medical knowledge to do things off label, which means the FDA has approved a product for the US, but only for a certain purpose or certain purposes. Doctors can use their medical knowledge and judgment to use it for a different purpose. And that is called off label. Okay. And that's legal for a doctor to do because the doctor's gone to med school and they've had all this medical training and they are using their best medical judgment. They're practicing medicine. It is not legal for other people to do that. So if you're going to somebody and you don't even know whether they're a doctor or not, like I would definitely ask them that question. And hopefully soon we'll have certified med spas so that, you'll be able to just know, are they certified or not? And for everybody at home, like tell all your practitioners, well, I hope you get certified once that's up and running. That sounds like a great idea. Anyway, so yeah, that's my next passion project. The whole book and the podcast has led to this crazy thing, but yeah, anyway, I really appreciate this conversation. So can you tell our audience how they can reach you?
Sure. Absolutely. So the best place, if you just want to find out about our practice or anything that we do, is our website would be the first place I would look, which is www.Restor Medical Spa, which is RESTOR, no E, medicalspa.com. We have information on all our procedures, everything, a lot of videos of me talking. If you think me talking is worthwhile, there's lots of videos of that on the website to explain the science behind what we do and that sort of thing. You can also find me on LinkedIn. My name is Flora Waples. There's only one of me, so it will be not hard to find at all. And yeah, I mean, definitely I would love to have people reach out. I love to think about science. I love to answer questions about science. Those are things I find really valuable and meaningful. So if there's any questions from today's episodes, send me a message on LinkedIn and we'll talk about it.
That's awesome. And we will have links to all those things in the show notes, so you can go straight to that. So Flora, thank you so much for being on the podcast today. I really hope that you can come back and talk about the other topics sometime soon.
Well, anytime. I had a wonderful time. Thank you so much for having me, and we'll do it again.
If you've learned something and like what we're doing, please tell your friends and give us a 5-star rating in your podcast app. If you have a question or a crazy story of your own you'd like to share, please send an email or voice recording to info@drkatedee.com. That's DRKATEDEE.com. Or reach us through the website MedSpaMayhem.com. And read the book. MedSpa Mayhem is available everywhere books are sold. Thanks for listening. This has been MedSpa Mayhem with Dr. Kate D. We are so grateful you're listening, and we hope you've learned at least one fun or possibly disturbing fact today. Don't forget to hit subscribe on your podcast app and leave us a 5-star review. And read the book. MedSpa Mayhem is available everywhere books are sold. Links and more can be found in the show notes and on MedSpaMayhem.com.